Hi. Before you can do the lab on physical and chemical properties, what we need to do is learn what these properties are and how you can recognize them in lab. Then when you go into lab, you're going to have a set of experiments where you have to decide if the changes you observe are physical or chemical. Alright, so let's start with physical properties. I've listed here some examples of physical properties. These are the properties of substances that really it's just kind of a part of how they're made and how they behave. Physical properties can be observed with your senses. So think about using your eyes, your ears, your nose to smell. Definitely don't taste things in lab, and your hands for touch. But you're not changing the substance, so remember that. For example, the melting point of water, or ice rather, is 0 degrees Celsius. And ice in this country melts at 0 degrees Celsius, and ice that's from China also melts at 0 degrees Celsius. It's just a property of ice. Same thing with boiling point, 100 degrees Celsius. Now with color and shape, you may be able to change the shape of that block of ice. It might melt and become water, so it has a brand new shape, but the formula for that substance is still H2O, so you haven't made a new substance. Density and mass are two properties that we're going to talk about in this unit also, so just keep in mind that the size of the object and how much space it takes up per mass are standards for every substance. Alright, so with physical properties come physical changes. We already talked about the freezing and the melting. You can also boil water and convert it into steam. Take, for example, a piece of paper. You could cut it into some smaller squares. You could ball it up and make a little piece of paper to throw across the room. But these are changes that don't change the identity of the substance. The ice and water is still H2O, and the paper is still paper, no matter what its shape. So those are physical changes. Now the other type of change you need to know about are chemical changes. So let's talk about chemical properties and how they relate to a substance's behavior. Chemical properties relate to how a substance interacts with some other substance, undergo a change. For example, when you buy brand new patio furniture at the beginning of the summer, usually by the winter time it started to rust a little bit. That's because there's a reaction with oxygen in the air. Also, the ability of some things to burn, like wood, while other things don't, like the wax on a candle. Some materials react with acid, others don't, and some materials will decompose when it's in the light. You buy hydrogen peroxide in brown bottles in the grocery store because of that. If they sold it in a clear bottle, the peroxide would break down faster than it does. Alright, so remember, chemical properties have to do with the substance changing into something completely new. So let's look at some examples of chemical changes. Think about when a plant dies out on your back porch in the winter. It can get rotten and just decay through the winter. Burning logs in the fireplace over the winter is an example. And this is kind of tricky, but cooking is a chemical change. Like when you grill hot dogs and hamburgers, you are cooking that meat and you're making it into something different than it was to begin with. Now I know sometimes people think, yeah, but it's still a hot dog. But really the chemical composition of it is different. You can't change it back to the way it was before. So whether you're grilling or making pancakes or scrambling eggs, any type of cooking is a chemical change. So when you go into lab, how are you going to recognize when a chemical change occurs? Let's look at some of the indicators that a chemical reaction is happening. Okay, so first of all, bubbling. Bubbling is really just production of some kind of a gas. It might be hydrogen or oxygen or carbon dioxide. Different reactions will be different, but any kind of bubbles are a good indicator. The next one is heat, and a lot of times the production of heat comes light. Now this next one you may not be familiar with, a precipitate. A precipitate is when a solid forms during a reaction, And I've got a video clip to show you an example of this, but your test tube, the substances in the test tube will get really cloudy or grainy, milky looking, and you can tell that you're forming something different that you didn't have in there before. And finally, an unexpected color change. Now I underline unexpected here because a color change, just coloring a piece of paper with a marker or a crayon, is a physical change. But if you get a color that you didn't expect, like if I add blue food coloring to water, it's going to be blue water. Physical change. But if I add two clear liquids together and they turn red, that's an unexpected color change. So that's an indication that some kind of a chemical change has occurred. So take a look at these examples and hopefully you can recognize them when you go into lab too.
And we have the oxygen here, and I have been asked about 12 times by various members of the staff to remind you, don't try this at home. I know you have the 900-gallon tank. I know you have the oxygen. I know you have the suit of Alka-Seltzer and a staff of 100 people. No!
So that we don't have to just stand here and talk and not explain it. Try it with these two. This is something my dad whipped up years ago, right?
Okay.
So here, pour it into here.
The little one into the big one,
all
of it this time,
absolutely. Kind of pour it all in there.
You see it there? Here we go.
There you go. So kind of pour it in there. And I'm going to give you a swirl right here, and then I'm going to give it back to you. Fair enough? Okay. So there you go. So hang on to it. Now, what we actually have going on here are the molecules literally are marrying up right now. So it kind of looks like it may change color just a little tiny bit. This is the part where you just cross your fingers and you hope that you see a color change. It looks faintly yellow, doesn't it?
Here it comes, here it comes.
This,
oh, how cool is that?
Absolutely beautiful. So we've actually created a new substance inside as those molecules kind of marry together.
It's not warm. It's not warm. I mean, there's no
it's
heat
just
to
a
the
color
reaction
change.
or anything.
So we're changing something from an acid to a base usually, and that's the indicator. And it's kind of a colorful way to do it.
That
here,
is
try,
too cool.
Try this one here. So when this one pours in, watch this. We'll see if we can go back clear, so that you go back to that colorless.
Sake. All the color comes out.
We're back again.
So
they're called chemical clock reactions, and on Google, if you just Google the clock reaction, I have a coolest one for you right here, one of my favorite ones. Ready? So here's what I want you to do.
Okay.
We're going to go like this. So these three, you're going to hold on to it, all right, so that we don't miss it. So 1 goes into 2, and 2 goes into 3, and now hold it up for everybody. Ready? Hold it up. nice job. Watch, it turns orange. Now don't move, don't move, and
it's changing
bam!
black.
Is that pretty?
That is
Isn't
just
that
amazing.
That's pretty.
The kids in your in the elementary school science classes and the high school classes must just love that.
Well, but it's a cool reaction that goes on inside. You want to see it go backwards?
Yes.
Okay. You want to see it go forwards? No, it's another joke.
So finally, To sum all of this up, if you have a chemical change occurring, that's really all a chemical reaction is. Here's the most generic way to write a chemical reaction. The reactants are those substances you start with, and they are written on the left side. Now, chemical reactions aren't written with equal signs like a math problem. They have an arrow in the middle, and the arrow separates the two. Products go on the right side of the arrow, and this is the new substance that you make. So keep all these things in mind, and I hope you have a lot of fun doing this lab next time in class. Bye!